No, can't hear me. There you go. Good morning for those of you joining us at home. Can you hear me okay?
Yeah.
Thank you. So today we are going to start chapter 4, which starts the second half of our class a couple days early, but we're right around that middle of the year time. If you are in school, you received a packet from me today that we will be using. If you're coming to school tomorrow, you will receive the same packet. So you're just going to miss the first page of notes. You'll have to take them on lined paper if you're at home. If you are not coming to school and you're at home, this is posted in Google Classroom, and you will want to send this to Notability, send it to Adobe, or you can just take notes on lined paper. That's totally up to you. But the worksheet or the packet for chapter 4 is posted to Google Classroom if you did not come to school yesterday or today, and you will not be here tomorrow. So we're going to talk about solving linear inequalities today in one variable. We're going to talk about graphing those linear inequalities, so a little bit of graphing. And then we'll talk about solving multi-step inequalities as well. The homework is a worksheet and it will be posted on Google Classroom halfway through class once we get to that part where we start the homework. As a little reminder, any makeup work from chapter 3 is due by 2 p.m. on Thursday. This includes the midterm exam. If you have not taken either part of the midterm exam, please make sure you do that. Those grades were posted to PowerSchool yesterday. So if you want to see how you did on the midterm exam, you can go to PowerSchool and you can see each day. And it's just out of 21 points each day. So I didn't multiply it by 2 or double it or triple it or anything like that. So day 1 was 21 points, day 2 was 21 points. I will release the actual test back to you when everybody has taken it. So it'll probably be on Friday after I have all my grades finalized so that you can kind of see the questions you solved incorrectly and look to see what the answer was. So again, anything that is missing from the midterm or from chapter 3, please make sure 2 p.m. on Thursday. That's my cutoff, 2 p.m. Thursday. That's the end of the school day. That's the end of the marking period, 2 p.m. You may have received an email from me yesterday. Please check your email, because that's the way that we can kind of contact you via email. Did you get an email from me because you're missing this work that you still need to hand in? Any questions on that? So if you can go in the packet to chapter 4, section 1. We are doing this entire packet, entire chapter. There are 6 sections. We will cover every single section. Turn to page 3. See if you can solve the 2 equations.
Yeah.
On page 3 is a little nice review. You might need your calculator out. Again, if you're at home, you can just take these notes on lined paper, or you can send the digital copy that's posted in Google Classroom to Adobe, or you could send it to Notability. Just writing it down on lined paper is fine as well, or any kind of paper, really. But remember, you are asked to post notes halfway through the chapter when we take a quiz, at the end of the chapter as well. So you are asked to take the notes that we're covering in class, and then I do collect them and give you credit for them when we're done with a quiz or a test.
All right. So we'll just go over real quick. Jason, what do we do for number 1? It's the first step. Yeah. Subtract the x over. X is crossed out. And then we're left with x minus 5 equals -3. What's the next step, Jason? All right, and what do you get? Okay, easy quick review. TJ, what's the first step here? Yeah, add x over. Josh, what do we do next? Good. And Haley, what's your final answer going to be? Yeah. That's it. Okay, so next we're going to start looking at some definitions. So we have different vocabulary. We have a linear inequality in one variable, solution of an inequality in one variable, and then the graph of an inequality in one variable. You want me to just?
It's up to you.
What? I don't know exactly what. Okay, so does anybody know what inequality is?
Here are inequality symbols.
You remember what those are? Yeah, greater than or less than. So what we're looking at is equations like up above, except we're going to have a greater than or less than symbol. So we might have x plus 5 is less than 12. Or it doesn't have to be x. You can use anything here. You can have like an s minus 4 is greater than 2. So these are just different examples we could have.
There are 4 different types of inequality symbols. So he has the greater than and the less than up there. What other 2 inequality symbols? You got that greater than, less than.
There's some we could add to these two. Yeah, you could put the equal. You also have a less than equal or greater than an equal.
So essentially, we're changing the equation, making an inequality by using one of those 4 signs. So really, we've been doing this stuff, we're just changing it and making it an inequality. You got it?
Yeah.
Let me change my screen.
Oh, what did I do?
No, it's not you. My recording.
Okay, the solution to inequality in one variable, it's the value that makes the inequality true.
And that's the same definition we set for an equation. The equation, the value that makes the equation true. It's the same definition, we're just changing it to say the word inequality.
It really is just, it is an equation, except the sign. Instead of equal sign, you have an inequality sign. Ooh. So it says graph of an inequality. So if we're using a real number line, it's all the points that make that equation or inequality true. So it'd be all this. So all the different solutions.
So this is going to involve like some type of shading. So it's not just x equals 2, it's going to be x is greater than 2. So we want to know what parts of the number line would show x is greater than 2.
And then the last one is a compound inequality. Anytime you have something compound, it has more than one. In this case, we're going to combine two inequalities that are joined together. Wow, our writing is really bad. I apologize.
It's hard to stand and hold an iPad and read at the same time.
I can't even walk and chew gum, so this is like a juggling circus act coming on. And then we can bind these together using, I'll put in quotes, and or.
You need a podium in here, something that you can like place it on.
I saw one on going on eBay from the Capitol building there. Anybody else see that?
Oh, yeah.
Little current events. Anybody else see that little podium on sale? $99,000.
You got that kind of money. You can buy a nice little podium for our classroom.
Who knew we're getting a little current events around here? Look at that. So there's properties of inequality. To write the equivalent inequality, add the same number to each side, subtract the number to each side, multiply and divide each side by the same positive number, or multiply and divide each side by the same negative number, and reverse the inequality symbol. So that's the big key to me, I think, is this right here, this last one. Everything else on here is exactly the same that we always do. When we looked at our two examples up here, well, if we add 5 to one side, we have to add 5 to the other side. Subtract x from one side, we subtract to the other side. Everything's exactly the same that we're going to do. The only difference is going to be this last one. It says when you multiply or divide each side by the same negative number, you have to reverse the inequality symbol. So that means if it was originally negative, you have to switch it to a positive. If it was a positive, you switch it to a negative. Does that make sense? Okay, so we'll look at some examples to do that. Josh, you want to read this for us?
In other words, solve an equality the same as you would an equation. The only difference is if you multiply or divide by a negative number, the inequality symbol reverses.
Good. So now we heard it from me, we heard it from the paper, and we heard it from Josh. We got it in there? All right, so let's do a couple examples. So it's to solve the inequality. Emma, what's the first step going to be here? Just think of this as, just think of this as an equal sign here. What would be our first step? Yeah. So we're going to add 4. These cross out. And we get x is greater than -2. That's it. Done. So really no difference at all.
So if you're trying to look at part B, think about what the first step would be if you're trying to solve that. This time it says y instead of x.
See if you can solve on your own. Take a second. Now in this one, the last step, we have to remember that rule that Josh read to us. So Peyton, what's our first step going to be here? Yeah. Subtract 2 from both sides. So we get -5y is greater than or equal to negative 15. And then what we're going to do next is we're going to divide by negative 5. Josh, what happens when we divide by a negative number? What happens to the sign? It reverses. So now it goes from this greater than negative 15, we're going to go less than or equal to. So everybody see how I switched the signs there? And then we know negative 15 divided by negative 5 gives us a positive 3. Jason, can you read us the next section here?
Graph an inequality in one variable consists of all points in the real number line that are solutions of inequality. To graph an inequality in one variable, use one open dot for variable and a solid dot for variable. For example, the graph of x less than 2 and x greater equal to negative 1 or something.
Good. And what we're going to highlight there is it says use an open dot for a less than or equal to, or sorry, less than or greater than, and then a solid dot when you have the equal to's there, a less than equal to or greater than equal to. And you can see here, the first one is x is less than 2. So on a number line, you put an open dot on 2, and you shade everything that's less than 2. So that's on the left side. Over here, it says graph of x is greater than or equal to negative 1. Since there's a greater than or equal to, instead of an open dot, we have a solid dot here. And greater means it's everything that's higher. When you're looking at a number line, you think left is less, right is greater. So now we're going to graph your solutions to examples 1. So we'll just rewrite these. We have x is greater than negative 2, and the other one we have is y is less than or equal to 3. So go ahead, take a second and see if we can graph this.
We need to take open, closed circle at negative 2. Based off of the greater than symbol, should it be an open circle or a shaded in circle?
Haley, for part A, is that an open circle or a shaded circle? Open, yeah, so we go to negative 2. We put a big open circle. It's greater than. Does that mean we're going to shade on the right side of this or the left side? It's greater than, more. The right side, so that means we're going to get everything on this side.
And if you look at the tip of the inequality sign, the inequality sign is pointed to the right. So the direction you shade should be the same direction that your sign is pointing.
Yeah, you can see that that's kind of pointing like that. It's a good tip there, Ms. Kane.
Yeah, I learned a couple after.
That's why they pay you the big bucks around here.
Try and learn some easy tricks along the way.
Oh, my, that looks pretty embarrassing. That doesn't have much of a tip to it there. That's best. Okay, so now, Peyton, is this going to be a open or closed circle? Yeah. So you put the dot and you close it up. And now are we shading on the left side or the right side of this? Yeah, the left. You just kind of scribble a line on there to make it seen. And that's it. Okay. Example 2, I'm going to do with you, okay? It says, now we have a variable, an example with a variable on both sides. So it says solve 7 minus 4x is less than 1 minus 2x. So we could start where we get the variables on one side. I'm going to choose to bring them to the left-hand side.
And I'm going to try and keep that consistent because you want the x to say x is less than, x is greater than.
Mm-hmm.
You want the x on the left side. Just like when we were solving an equation, we always try to say x equals. So we're going to try and keep the x always on the left.
It makes it way easier reading it. So we get 7 minus 2x is less than 1. Haley, what's my next step? Yeah. What do you get when you subtract 7? Yeah. And Josh, did I need to change my sign here?
Not yet.
Not yet. That's only when you multiply or divide by a negative.
He was trying to trick you, Josh. Not evil.
Now, Josh, what's the next step? And this is where the sign switches, correct. So now, since we divided by a negative, the sign is going to switch from a less than to a greater than. And then negative 6 divided by negative 2 is going to give us a 3. TJ, are we going to put an open dot or a closed dot on 3 when graphing? Open, absolutely. So you go to 3, you put an open dot. Jason, are we going to shade to the right or to the left? To the right, yeah. You're going to shade to the right. That's it.
And there should be 4 checkpoint examples at the top of the next page. See if you can work yourself through some of those checkpoints.
Around to help. If you're online, we can answer questions for you.
If you have questions about example 2, let us know as well. Penguins start playing tomorrow night, Mr. King?
Tomorrow night.
Tomorrow night?
That happened quick.
Holy cow, they practiced for like a week.
That's crazy.
Any Penguins fans in here? Yeah. Something hopeful after that Steelers loss.
Oh my God, that was so bad.
That wasn't good. It was not good.
It started off really bad, and I felt like that just kind of set the tone of the game.
My boyfriend.
Yeah.
He's like, nope, I'm not taking it.
So hopefully the Pens will pull us through. Get us through the spring, into the winter. All right, ready to go over? How are we doing?
All right. Good, Haley. Walk me through A. We'll go quick. Okay, what do you get? Okay, open or close circle? Open and shade to left or right. Got it. That's it. Peyton, can you walk me through B?
subtract 4 from the side.
Yeah.
X is greater than and equal to -1.
Okay, that's a less than or equal to, and that should just be a 1 there. And then now, oh, so you're giving me the final answer. You got it. So now you're going to divide by -1. And now when you divide by the negative, this is where the sign switches, and that's where you gave me the answer, where x is greater than or equal to -1. So there's an open or closed circle there. Yeah, close it up on -1, left or right. Got it. Emma, what we get for C? Awesome.
2x is greater than divide by 2. And x is less than -2.
Okay, good. And I'm glad this one came up. Now when we divided here, we look at the sign. What was the sign? Was a positive, right? Only when it's a negative do you need to switch the signs. So I'm glad that's why we had this one here, because it's a little bit tricky. Only when you divide by a negative, the sign changes. In this case, it's not, because if we divided by a +2 here. Does that make sense?
Even though there's a negative number on the other side, we didn't divide by a negative number. That's why we kind of throw in these problems, just to make sure that you're thinking about how you're writing your answer.
Okay, and then this is going to be an open circle on -2. And then, Emma, is it going to be on the left or the right of the shape? If it's greater. Yeah, the greater is on the right. Then the last one. This one's a little tricky. Josh, what do we do first?
You subtract -2x this side.
Okay, remember, our rule is we want to try to keep all the variables on the left side.
So or you can just add 3.
Okay, you could add 3, or you could subtract the x. So either way would be good. I'm going to subtract the x over, just to get our variables together first. And I also want to show you what you would get here too. So when you did this, Josh, 2x minus x just leaves you with an x minus 3. And then what does x minus x give you? With those cross out, what is that? 0, good. And then now is when you could add that 3 over. The signs change? Nope. Open or closed circle, Josh?
It would be
Left or right? Got it. Okay, any questions on those 4? Are we going to stop there? Okay.
So take out your iPad. We'll pull it up on the screen as well. There is a worksheet posted in Google Classroom, so everybody at home can do the same thing. So if you take out your iPad, go to Google Classroom. It's posted at the top of the stream on the first page. It's also posted in the classwork for today. So clicking on the attachment, we have this practice worksheet for section 4.1. And I want to go over the first couple with you. So let me get this downloaded for me myself as well. Here we go. So the first 6 questions ask you to decide if the number that they give you is a solution. And it's written a little weird, but this number after the semicolon is a 1. We want to know, is that 1 a solution? So that's the number that we're plugging in for x to decide if it is a solution. So 2x plus 1 is greater than 3. We're going to replace x with 1. So 2 times 1 plus 1 is greater than 3. So we're just taking that number, plugging it in. So Peyton, 2 times 1 is plus 1. What's 2 plus 1? 3. Is 3 greater than 3, Peyton? No, it's equal to 3, but it's not bigger than 3. 3 is not bigger than 3. So that is not a solution. So you just write no, not a solution. Let's try the next one. Same type of problem. They give us the number 3. That's what we're plugging in for x. So whatever is after the semicolon, you're plugging in for x. 4 times 3 minus 12. Is that less than or equal to 0? Oh, and I wrote 10. All right, Haley, what is 4 times 3? 12 minus 12. What's 12 minus 12? Is 0 less than or equal to 0? Yes, because it also says equal to. 0 is equal to 0. So this one's a yes. So we did those 2. The next ones are matching. So we're going to match the inequality. And number 7 says x is greater than or equal to 0.
What letter is that?
One letter would be x is greater than or equal to 0. Make sure it says equal to as well. So if it says equal to, we're looking for a closed circle. And why don't we cross off 8 and 9? Because we didn't talk about those today. So that means we're going to cross off option F and A. So let's cross off 8 and 9. And that takes away option F and option A. So what option? Which one says x is greater than or equal to 0? We have B, C, D, and E to look at. Which one does it look like, Peyton? Do you know? Yeah, it's C. So here's 0. Greater than means shade to the right. So number 7 is C. So you got a couple matching. And then the last couple of problems are solving. 13 through 18, you do not have to graph. We skip a whole bunch, and then we go down to 25 and 26. There's a graph with 25 and 26. So those would be then the problems that you're graphing. So you still have 7 minutes, 8 minutes. What time is this over?
17.
Okay, 6 minutes. It's 10:11. You have 6 minutes. So I'll just look at this first one. This is easy. I would just add 1 to both sides. X is cancel, and we end up with x is greater than 3. So that would be my answer for number 13. So again, you're solving the inequality. 25 and 26, those are the only 2 that you're graphing. There's a graph drawn underneath it for you to use. Anyone have questions? I think you should be able to like cruise through some of these. They're pretty easy questions. 1-step problems. Gets into 2 steps at the bottom there, 25 and 26. And those are the last 2 problems that you have to do. So the first group checking, the second group matching, the third group solving.